Okay, so when you are drawing covalent bonds, you're going to treat it just like ionic bonds. So you're first going to start out with your Lewis dot structure. So if we're looking at our first example, H2O water, you're going to draw oxygen. If you remember, oxygen has 6 valence electrons because it's in that 16th column. So we're going to do our 6. 1, 2, 3, 4, 5, 6. And then it's got 2 hydrogens. Hydrogens only have 1 valence electron and they only need 2 to act like a noble gas. So oxygen needs 2 more. Hydrogens, both hydrogen just needs 1. So with these, instead of drawing our arrows like we do on ionic compounds, for covalent compounds, you're going to take your lone or your single electrons and you're going to draw a ring around it. So I think about it, all the single ladies, put a ring on it, right? All the single ladies, put a ring on it. So if you're looking at this now, if you look at oxygen, you have 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is sharing this pair as well, so each of those hydrogens have 2 and everybody is happy. Okay, so if we're looking over at bromine, Br2, that's one of those Hofbrinkel molecules, you're going to draw your Lewis dot structure. So bromine's in the next to last column, so it has 7 valence electrons. So I'm going to go ahead and draw that out. This one also has it. So 1, 2, 3, 4, 5, 6, 7. Each bromine just needs 1 electron. So those single ladies, they're going to put a ring on it, and it's going to have a covalent bond between each of these bromines. If we look at our last one, which is CBr4, we're going to do the same thing. So if we're looking at carbon, carbon has 4 valence electrons, so you're going to have 1 electron on each side of the C. And then you're going to draw your bromine molecules, which all of them have 7 valence electrons. So we're going to line those up just like this. Yes, you do have to draw all of the electrons around it. I know it sounds redundant and annoying, but you got to do it. And then we're going to put one more up here. 1, 2, 3, 4, 5, 6, 7. And so carbon is going to need a total of 8 electrons. Bromine is also going to need a total of 8. Carbon has to gain 4. Each bromine only has to gain 1. So all the single ladies, you're going to put a ring on it. And at that point, they're sharing. Now, we can't just stop there. With covalent bonds, what we're going to do is we're going to look at something called a Vesper model. And a Vesper model is when you are looking at what shape are these atoms going to take shape into. Because if we think about our electrons, remember, like and like repel, opposites attract. So the electrons are going to want to be as far apart from one another as possible because they don't like to be next to each other because they're both negative energies. And so what happens is that we have this Vesper model, meaning that based on how many electrons they have, will tell you what shape they're going to be. So there's a couple things that you need to keep in mind when you're looking at these examples. The first one is you have to determine what's your main atom. And your main atom is going to be the atom with the most molecules bonded to it. So if we look at this one, oxygen is our main atom. And it's our main atom because it has 2 different things bonded to it. So you have to identify that first. Next, what you're going to do is you're going to look at your main atom and see how many things are bonded to it. So this hydrogen is 1, this hydrogen is another, so you have 2 bonded atoms to your oxygen. Okay. And then the last thing you're going to look at is you're going to look at this oxygen and you're going to look at lone pairs of electrons. So these are going to be the electrons that are not actually within a shared bond. So if we look, both of these electrons are in that shared pair, so our lone pairs are going to be here and here. So we have 2 lone pairs. Then you're going to use this chart and you're just going to look that up. So we're looking for 2 bonded atoms and 2 lone pairs. So if we look on here, we have 2 and 2. That shows us we're going to have a bent shape, right? Bent 2 and 2 with a bond angle of 109.5. And then I want you to come over here to these shapes and see what does a bent one look like. So if we look at a bent shape, we're going to be looking at this one here. And we're going to redraw it based on that shape. So our oxygen is our middle atom. I'm going to make sure you put the lone pairs. And then it's bonded to 2 hydrogens. That's going to be your final shape that you have for your molecule. So let's do the same for these other two. If we look at bromine, it doesn't matter which bromine you take as your main bromine because they're both the same. So let's just make this one our main atom. Okay. If we look just at this bromine, we're looking at how many things are bonded to it. This bromine is bonded to it, so we have one atom bonded. And then if we look just at this bromine, we have 3 lone pairs, electrons that are not being in the bond. So 1, 2, 3. 3 lone pairs. So we're going to look at this at the bottom. We have 1 bonded atom. We have 3 lone pairs. So you're going to go down the chart, tell me where you can get to 1 and 3. Okay, so we see we have 1 bonded atom, 3 lone pairs. That makes it a linear shape with an angle of 109.5. So it's linear, 109.5 degrees. If you go over here and we look at a linear shape, it's just going to be like a straight across picture. So our shape's going to be BR, BR, and yes, you do have to draw the lone pairs for each of the molecules. Okay, one last one, and then I'll let you get to practice. So if we're looking at this CBr4, our main atom is going to be carbon because it has the most atoms bonded to it. Right, so this is our main atom. If we're looking at carbon, it's got 4 different things bonded to it. 1, 2, 3, 4. So 4 bonded. And if we're looking just at carbon, there are 0 lone pairs because every electron that it has is going to be in a bond. So 0 lone. So you're going to be looking at this chart. Where are our 4 bonded and our 0 lone? So we have 4 bonded, 0 lone. That's going to be a tetrahedral. Tetrahedral with a bond angle of 109.5. That's a popular one that we're going to use. Okay, so if we look down here, our tetrahedral molecule is going to look like that. We're going to do the best that we can to redraw that. So we've got carbon in the middle, a bromine on top. Then you're going to kind of do a tripod thing here. Put a bromine, another bromine, and a final bromine. And yes, you do have to do your lone pairs. So I know it's a lot of drawing, but overall, it's not that bad in the scheme of things. So you're going to do that and that, and that, and that. All right, I'm sure that you're going to have questions when I come back to school tomorrow, but I want you to try your best to get everything done on the back or do as much as possible, and then we'll talk about it. But other than that, good luck, and we'll talk about it when I get back.